My name is James Heater from Greenpeace, and I have a message for you and for the Metals Company. We are here as guests in these waters to deliver this message to your company, a Canadian company which is set to cause huge and irreversible harm to the global oceans if you continue to pursue deep sea mining.
You're having a dream. Here's the reality. Oil, natural gas, and coal provide 84% of all the world's energy. That's down just 2 percentage points from 20 years ago. And oil still powers nearly 97% of all global transportation. Contrary to headlines claiming that we're rapidly transitioning away from fossil fuels, it's just not happening. 2 decades and $5 trillion of governments investing in green energy, and we've barely moved the needle. This was supposed to be easy. Why is it so hard? In a word, rocks. To get the same amount of energy from solar and wind that we now get from fossil fuels, we're going to have to massively increase mining by more than 1,000%. This isn't speculation, this is physics. Copper, iron ore, silicon, nickel, chromium, zinc, cobalt, lithium, graphite, and rare earth metals like neodymium. We need them all. And then those metals and materials have to be turned into motors, turbine blades, solar panels, batteries, and hundreds of other industrial components. That also takes lots of energy, which requires even more mining. As a World Bank study put it, these green technologies are in fact significantly more material intensive than our current energy mix. That may be the understatement of the century. Raw materials account for 50 to 70% of the costs to manufacture both solar panels and batteries. Until now, it hasn't really mattered that much because wind and solar still account for only a few percentage points of the global energy supply. They're an applause line for environmentalists, not a major energy player, and it's unlikely they will be in the foreseeable future. But for the sake of argument, let's say we sharply ramp up mining. Where would these new mines be located?
Hidden Gem is Aussie's first deep-sea mining vessel, which is a converted drilling vessel. It has a crew on board of 130 people. We have just completed the first pilot project for Aussies, which was in conjunction with TMC. This was on the Nori D field in the Pacific, where we had to collect nodules at a depth of over 40 kilometers.
My background is primarily deep water exploration and production systems in the oil and gas industry, and that technology has been the basis of the designs for our riser system and the collector system that Aussies have designed in-house and built in-house.
The collector is divided into 3 systems: the pickup system, the processing system and the transfer system. My job on board was to commission these systems and the pumps in these systems to be able to pick up the nodules as efficiently as possible and to reduce the sediment intake into the collector. The collector uses hydraulic flow to pick up nodules and transport them into the hopper. In the hopper they settle through the bottom, and then they are transported upwards through the vertical transport system. Inside the hopper we have a system of pumps that separate the sediment from the nodules, and the sediment is discharged through the diffusers. So the diffusers are used to slow down the flow of sediment coming out of the collector, and they are helping the sediment to settle down as fast as possible.
When we start building the riser, we hang off the jumper onto the drill floor, and then we start building from the drill floor, first in small sections, and then lowering down one by one. And the riser itself is over 4 kilometers. The riser system works by pumping air at the depth of 2.5 kilometers, and then by pumping this air, the density inside the riser will reduce and be lower than the density outside the riser, and that's including the nodules. So the water will start to flow pressure wants to equalize, and that's how water and the nodules and the air will go up.
We see a future where the ocean is protected, where the ocean is thriving. There is no place for deep sea mining in this future. We know that the hidden gem has been test mining in the deep, intending to pull up 3,600 tons of minerals from the ocean floor. This activity, by risking carbon disruption and threatening biodiversity, puts ocean health and therefore the health of our planet at risk. The movement to stop deep sea mining and the companies behind it is strong and is growing exponentially. In the past few weeks, the government of Aotearoa, New Zealand, Germany, Chile and France have all spoken out against deep sea mining. They join the governments of Palau, Samoa, Fiji and the Federated States of Micronesia, which have formed an alliance backing a moratorium, and many more are voicing concerns.
Yeah. What's the worst case scenario? Plan out in your head how it's all gonna go. So you think you got it covered, but there's always something new that you discover you've not thought about. You can never figure out every possible outcome.